Today we're starting 1.5, solving equations with variables on both sides. So our main goal today is going to be solving equations that have only one variable, but have the variables on both sides. Now to solve an equation with variables on both sides, you still have to use the inverse operations to collect the variable terms to one side of the equation. We've got to get everything that's alike to one side. The equations are usually easier if we're going to deal with it, the variable that has a positive coefficient. So that's usually what decides which way we move the variable. So we have 7n minus 2 equals 5n plus 6. First thing I'm going to do is just like my other problems. Draw my wall. But what's different about this problem compared to the other ones? There are variables on both sides of my equation. I either have to move all the variables to the left, or I have to move all the variables to the right. We want to move it so we have a positive variable. Where are there more n's at? On the left or on the right? On the left. So I've got to move this 5n. How do I move something from one side to another? How do I move this 6? So what sign is really in front of this 5n? Positive. There's really a positive sign up front. So how do I move a positive 5n? Subtract or negative 5n, negative 5n. Now I have 7n minus 5n is what? 2n. Nothing happened. 2. That's gone. And I'm left with 6. Now this problem should probably look like the ones we've been doing in class. What's going to move first? The minus 2. How do I move a minus 2? Add 2. Add 2 here. Add 2 here. I have 2n equals, what's 6 plus 2? 8. What's my next step? Divide by 2. Divide by 2. N is 4. Now for this problem, we got an answer of 4. We want to double check to make sure I did this correctly. I don't have to write down anything extra. I can do everything in the calculator if I want. 7 times, what's my n? 4 minus 2. 26. Now let's do the other side. 5 times 4 plus 6. These two are equal to each other. Is 26 equal to 26? So I know I did it correctly. Now before anyone asks, do I have to move this 5n to the left? I'm going to show you the other way. Instead of moving the n to the left, let's move it to the right. So which one's going to move? How do I move this 7n? Why am I subtracting? Because it's really positive, so I need a negative 7n, negative 7n. Notice how I'm lining things up. If you line things up, the better you're going to be at getting them done correctly. I'm not going to be mismatched. Gone. Negative 2. What's 5 minus 7? Negative 2n plus 6. Variables on the right-hand side. What do I need to do now? Subtract 6, subtract 6. When I'm dealing with subtraction, I like to think of it as negatives. What's a negative 2 and a negative 6? Negative 8. If you borrowed $2, you borrowed 6 more, you borrowed $8. Negative times negative is a positive. Negative divided by negative is a positive. But with addition and subtraction, if they're the same, it stays the same. If they're different, the bigger one takes the sign. What's my next step? Why do I need to divide by negative 2? Because it's a multiply by negative 2. Divide by negative 2. divided by negative 2? What's negative 8 divided by negative 2? Still got 4. Just had a negative throughout the problem. I know it's a negative 2n, but it's negative 2 times n. So you have to divide, not add 2n. Now this problem here, everyone had a chance to look at it and try to get started. Does it matter which way I move things? No. By coming around, I saw a lot of you move the 3 over because the 4 is bigger. That's fine. What do I need to do? Why subtract 3b? Because it's a positive, I need to subtract. Negative 3b. What's 4b minus 3b? b. 1b. 2 comes down. This is where people made mistakes. The equal is still there. The equal does not go away. What's 3b minus 3b? What is 0? The equal 0 just doesn't disappear. And that's a common mistake. People just get rid of it and then put b minus 2 and then say b is negative 2. Or say, sorry, b is 2. What do I need to do now? Subtract 2 over. Subtract 2 over. b is negative 2. Now I can substitute this back in. 4 times negative 2 is negative 8. Negative 8 plus 2 is negative 6. So in this one it's negative 6. 3 times negative 2 is negative 6. Negative 6 equal to negative 6. I'm correct. That's method 1. Do I have to always move it from small to big? If I would actually moved it the other way, I moved the 4b over. Negative 4b, negative 4b. Gone. 2 equals what's 3b and negative 4b. Negative 1b. If I had $3 I was going to spend 4, I still need $1. So I have 2 equals negative b. Do I want to know what negative b is? What do I care to know about? I need to know what b is, not what negative b is. So really what I'm doing in theory is times by negative 1, times by negative 1. Negative 2 is b. That is my answer. This one might have taken a hair less work, but you had to think. What's different about this one? There's decimals. Give it a try. What's my first thing I should probably do? Draw the line. My second thing I should do, I need to move a variable. I need to decide which one I want to move. I'm going to move the 3 to the right. Do I have to move the 3 to the right? No. I can move either one. But this one's easier because this is bigger. 70 cents is bigger than 30 cents. I have plus 0.3y, so I'm going to subtract 0.3y. Subtract 0.3y. 0.5 equals, what's 0.7 minus 0.3? 0.4. No more calculator needed. Okay? I need to add 0.3 because it's a negative 0.3. Add 0.3, add 0.3. 0.4y stays the same. What's 0.5 and 0.3? 0.8. What's happening to my variable? My variable is getting multiplied, so I need to divide by 0.4, divide by 0.4. Now, this is where you don't even need to grab a calculator. What could you tell me about both of those decimals? How many decimal places do I have? So if I can move this one, and I move this one. Whatever I do to the top, I have to do the bottom. What does it say now? 8 divided by 4 is 2. No calculator needed. It is not 0.2. The decimals do not just come straight down. I think some of you did that. You got to be careful of your decimals. To check that I did it correct. 0.5 plus 0.3 times 2, 1.1. 0.7 times 2 minus, what is it, 0.3? 1.1. They are equal to one another, so I know I did it correct. This problem here is a little bit scary at first when you look at it. 4 minus 6a plus 4a equals negative 1 minus 5 times the quantity of 7 minus 2a. It's a problem that goes on forever, it seems. For this problem, I'm going to treat it like there's two problems going on here. I have this right here. I have two expressions. I'm just looking at this piece. 4 minus 6a plus 4a. Anything I can do there? Yes? It's not 4 minus 10a. Why? Yes? Add the variables. You combine like terms. What's a negative 6a and 4a? Negative 2a. See, the common mistake is a lot of people will go like this. 6 and 4 is 10, then throw the negative on. That is not following your order of operations. All I did is took 4 minus 2a. I take the negative 6a and the positive 4a and put them together. You have $4, you're going to spend $6, you need $2 more. Now let's worry about the second side of the expression. What do I need to do here? I need to distribute. Negative 1. What's negative 5 times 7? Negative 35. The negative 5 has to go here too. What's negative 5 times negative 2a? Negative times negative is positive 10a. So now it's broken into two problems. How did I do the first part? I combined my like terms. The negative 6a and the positive 4a. Because they're on the same side, they just go together. Negative and a minus is the same thing. Because if I ask you to write the sign for a negative, you're going to do this. If I ask you to write the sign for a minus, you're going to do this. This is something we did in the first day of class, talking about the positives, the negatives, the addition, the subtraction, how they all have the same signs. All right, nothing I can do over here. 4 minus 2a. Anything I can do over here. What can I do? What's a negative 1 and a negative 35? See, notice how I'm not saying negative 1 minus 35. Because when I say negative 1 minus 35, you automatically think it's 34. That's the common mistake. But I think of it as a negative. Negative 1 and a negative 35. You owe $1, you owe 35 more. You owe 36 plus 10a. Now I've done all this simplifying. Now I can start my moving things. Draw my line. Let's move our variable. You want to move the 2a. Why do you want to move a 2a? Because it's less than the 10. That's fine. How do I move this negative 2a? Add or positive 2a. Positive 2a here. Positive 2a there. 4 comes down. That's gone. negative 36. What's 10a plus 2a? 12a. Now I need to move what? Move the regular number. What's the regular number that's going to move? 4 is okay by itself. I need to move what's over with the variable. So I need to move this 36. How do I move this negative 36? Add 36. Add 36. 4 and 36 is 40 equals 12a. Why do I need to divide by 12? Because it's multiplying. Divide by 12, divide by 12, a equals. Now I have this right here. I'm not going to write 40 over 12. What goes into both numbers? 3. 3 doesn't go into it because 4 plus 0 is 4. 3 doesn't go into 4, so 3 doesn't go into 40. 4. How many times does 4 go into 40? 10. How many times 4 go into 12? Can I do anything with 10 over 3? My answer is 10/3. You're allowed fractions as answers. And this is probably where you should go in and check to make sure you did it correctly. It might take you a while to type it in, but if you're checking your work, it's worth it. 4 minus 6 times 10/3 plus 4 times 10/3. My 4 didn't come in. Okay, I typed it in correctly. That's that answer. On the other side, negative 1 minus 5 times 7 minus 2 times 10/3. Did I get the same answer? Since I got the same answer on both sides, I know I'm correct. If your answers do not match up, you either made a mistake in the answer or made a mistake typing it in the calculator and checking your work. Questions? These problems take a little bit to solve. They're not got an answer. This is why at the beginning of the year I said you got to show your work. Because now the problems are taking a little bit longer and you need to follow what's going step by step. The neater you are in being organized, you're going to make less mistakes. The common mistake in algebra, you lose a sign. And by losing a sign in the beginning of the problem, it messes up the rest. And I need to see your work so I can see where that mistake was made. Because if I made a mistake here and wrote positive 36, what happens now? Yeah, it's going to mess up all of this stuff. Because I'm going to go, all right, add 2a, add 2a. I have that step right. Now I'm going to subtract it over. And you're going to get the wrong answer. But when I look at your work, I'm going to see, okay, you did that step right. You did that step right. Okay, you knew you had to add it, but you made a mistake in your math here. So I circle this and keep following what you're doing. Did this one mistake affect anything else? Of course it did. But I'm seeing, did you do every step after that correctly? You did, I take off less points. You need to show your work.